Hi. So in the previous sessions, as we have seen a lot about the background of the machine learning, we have seen the mathematics, algebra and stuff like that in machine learning. And now we'll sort of get introduce ourselves to machine learning, and we'll see what are the algorithms and what are the different things that we can do with the help of machine learning and how to do that. Now we are at the how part. So you basically know what you can do with the machine learning, but now the question is how you can do that. Okay, just a bit of revision so that you know where we are going to see. So we started with machine learning, and there we defined something called as task. So task means anything that you have to do. So we saw there are at least three types of settings in machine learning. The first type of setting was supervised machine learning, and then we had unsupervised, and then we had reinforcement learning. In supervised setting, if you remember that, in here we had data as well as labels. For example, we had spam email, let's suppose. So we had emails, and then we had spam or not spam. So these emails were our data points, and these were corresponding labels. This not spam and spam were our labels. Okay, this is called supervised because we were guided by this principle that we have to get these labels out of this data. Then we had something called as unsupervised learning. That was, there were no labels. Basically, we had just been given data points, and based on these data points we have to cluster them together. And for example, some data was given like this. So some data, for example, is given like this. And then if you see, there are two separate clusters in this. So without even having the labels, we can cluster them. Okay, so clustering is one of the types of unsupervised learning. So basically what unsupervised learning means, there is no label given, there is just data, and you have to make sense out of the data. Then there is reinforcement learning. Reinforcement learning is a type of machine learning in which what we try to do is we try to get feedback. We have something called as a reward function, or maybe utility function people call it sometimes. So so there are two phases. We have states, and when we take a decision based on the state, we go to next state, and we'll get some reward. And if the reward is like positive, then we'll keep on exploiting that state, and then there are some other state which we have to explore. So it's basically you are reinforcing the things. So that is the concept of reinforcement learning. So this was at the higher level. I just wanted to sort of revise you these things. So what are the types of machine learning? That these are different types of tasks, and we have done a lot of. We have seen in detail what are different types of like transcription, and then transcribing. We have seen the image recognition and stuff like that. So again, to go what data looks like. So here, as the machine learning algorithms, most of them they work on data. So here the data is represented by D. It basically is a set. Let's talk about supervised learning. So supervised, so there will be a bunch of data points. Let's suppose x1 will be there, and corresponding y1 will be the label. Then we'll have a data point x2, then y2 will be the label. And let's suppose we have n data points, so there will be y xn yn. So this will be our set, and here each the data point will belong to some vector space. That's where now vector spaces come in. If it's a real vector space, so what will happen, this xi, it may belong to, let's suppose, rd means like every value is a real number, and it is in d-dimensional space. Then this can be some complex number, maybe for example a number or something else. So what we have is, let's suppose we have we'll take an example of, we have been doing a lot of examples in that we had a data point like this, and then we had features. Let's suppose if we have 1 2 3 till, let's suppose, d features. So let's suppose this is an x1 data point. So that's why now this data point belongs to this, lies in this rd, because all the values are real, and these values over here, they are real. That's why we write it like this, and the d means it has a dimensionality of d, so it lies in that dimensional space. And this setting, as we know, that we have labels also. So this is a supervised learning setting. So because here we have labels as well as the data. So then the question is that now we can have these labels can be of different types. We have seen it can be a classification problem. So what is the meaning of classification? So classification basically means the labels that we have, they take some discrete values. Let's suppose classification, I'll say spam or no spam. This is a classification problem. So then we can have, let's suppose we define a problem in which we are given images. So images of handwritten digits. It's a really, really famous problem people usually solve in their beginning. So then there we have the images of 0 1 2 till 9 these digits, and we have to recognize these digits. Now, each image may belong to one of the classes. So that means we have 9 classes over here. So classification means you have a limited set of classes. That is, these set of classes can be counted. So we had binary classification in which we had only 2 classes. Let's suppose this spam, non-spam, or maybe some other examples like if you want to detect a disease, medical disease, it is either diseased or not diseased. Or either sometimes we have detected fraud detection, so it is fraud or not fraud. So then we have multi-classification problem, which is this digit recognition, or maybe some other image. Let's suppose you have 10 different types of objects, and you have a lot of images in which you want to classify these images to their object type. So there can be greater than 2 classes. So this is the classification thing. So let me write it formally so that you are clear with the notation. So this D here means data set, because I'll be using this notations always. So please keep this keep this notations in the mind. So xi, this will be a data point. So if I write xij, so this will be a feature of data point. So this will be jth feature of ith data point. And then I'll write yi. This means label of ith data point. So this here is ith data point because the xi. Then we'll have the c. C means classification label space, the label space. It also is a vector space. It can be a real number or it can be something else. Most of the times we'll be using real number. For example, if we have the binary classification, we'll write 0 or 1. Spam, no spam. So if you have, let's suppose 5 classes in which we have dog, cats, lion or something else we have to detect, and then we'll write 0 for, let's suppose, dog, 1, 2, 3 and 4. So these 4 numbers we'll be using. So this is the label space, the C. Okay. Then I said in the what's the difference in the binary classification problem? Binary classification, this C can take only 2 values. This C basically take values either 0 or 1, or sometimes we'll write +1 or -1 also. Okay, or sometimes 1 or 2, howsoever you want to do it. So this label space can only take 2 values. This is binary classification. Then I said about a multi-class classification. Multi-class classification. The C can take values from 0, 1 to k. There'll be k classes and we'll call it k, and here k is greater than 2, greater equal to 2. It's like it will become binary if it is 2. If it's greater than 2, we'll call it multi-class classification. Then we have special type of classification. We call it regression. Basically, regression is when there are uncountably infinite number of classes. When you want to detect a value which can be on any scale. Let's suppose you want to based on the features of weather, you want to say predict the weather. So there it can have values which will range from, let's suppose, minus some 10 degrees Celsius to, let's suppose, 37 degrees centigrade. Usually in Kashmir, so this is the range. So it can be anywhere in that range. Okay, so this is the regression. So C here belongs to the real number. So C will be the real number. Okay, are these points clear?
Yes, sir.
Nice, great. So what I'll do is I'll take some examples again. So based on these examples, you will get to learn why the machine learning is used. Again, the first example I always use is patient data. Patient data is that you will have each patient's records. So XI means ith patient record will be there. So let's suppose we are detecting a heart disease, let's suppose. So we are seeing if a patient has the heart disease. So based on, let's suppose he has MRI scans and he has some age, other features as well. So XI, so he will have different features. Like he'll have features XI1, XI2, and so on till, let's suppose, XID. These are the features he'll have. Then there will be a corresponding label. So YI, let's suppose, is 1 for this. Okay. So this will call at one data point. So one data point will be there in the patient's record. Similarly, in the text document, so there we can break down the document into like set of sentences or something like that. So each document, or maybe within the document, each sentence can be a one vector. So usually, if we classify, like let's suppose second problem will be classification of documents. As you know that in the web we have a lot of documents and you want to classify them. Let's suppose some document will be in the financial category, some will be in, let's suppose science, mathematics category and stuff like that. So there will be different categories of the documents. So you have to classify these documents. So what will be there in the documents? So in the given data we'll have xi. So there will be a set of vectors. Okay, xi will be a vector which will represent the document, and then correspondingly there will be a label given to it. So label can be your 0, 1 till, for example, however many classes we want to classify it. Then we'll have images, let's suppose. So image classification we'll have to do sometimes. Okay, image classification. So this you will study about this document. This usually people call it natural language processing, because documents are written in natural language and we have to process it. So image and this videos we call it computer vision CV. So these all fall basically under the machine learning realm. So in the first lecture, if you remember the Venn diagram where we actually draw that Venn diagram and I showed you what are the subsets of these things. So it was called AI initially, then turned into machine learning. Then we have all of this stuff, all of this thing into that tree. So in image classification, you will have an image. So image is nothing but a bunch of pixels, and these pixels will be flattened up. Let's suppose we have an image like this. So it is basically made up of pixels, and pixels have some values. So now we'll flatten this vector. So this vector will be like, it has these features. Let's suppose if it is 28 cross 28 cross, so it will have 784 features. So one image will be represented by that, and then we'll have a label. Let's suppose this image is of cat, a dog, something like that. So these are some examples. Now you know all of the stuff. So this was just a quick revision of whatever we studied in the previous lectures. So now we'll go into the meat of today's lecture that I wanted to discuss. Okay. So thing is, given data. So problem here is given data. So we have given some data. If some data is being given to us, the point is we have to classify it. We have been given data, and we have to classify things. Okay, that's the question we're interested in. So right now we're dealing with the classification problem, let's suppose. So here data is as I represented by xi, okay, and we want to classify, we want to get some yi corresponding to that. So this part we have to learn it here. So here we'll call it learning. Okay, what do I want to learn? So mathematically, if I am speaking, mathematically I just want to learn a function. So I just want to learn a function. Let's say function f or function h. Okay, so I basically want to learn this much. So I want to learn this function h such that if I give xi to this function h, it should give me correspondingly a yi value. So this is what I want to learn. So this is my query point, I'll call it, or input data point, input, and this is its label, and this is the learning function I want to learn. This is my function. This is the whole task we had to do in machine learning. Mathematically speaking, this is the whole machine learning if you see this equation. So you are in search of a function which on giving an input, it should give an output which you desire. Okay, then we have a what is called as hypothesis class. So there is a big, we'll write h, this is called as hypothesis class. So what it means is that there will be a huge number or maybe infinite number of these functions, this h, there will be infinite number of functions, but we have to choose an appropriate function so that it will sort of give these labels, and we'll call it, it'll perform better, it'll minimize the loss, we'll call that. Okay, so we have to find h which belongs to this hypothesis classes, because there will be a lot of functions from which we'll have to take a function which suitably does the classification for this. Okay, so this we call it hypothesis. Like, I'm purely speaking from the mathematical point of view, if you ask me. Okay, so we have, let's suppose, some algorithm over here. Okay, we'll give some data. Okay, we'll give some data to the algorithm will try to find this h. That's the job of the algorithm. And then what we'll do is, so we'll now take this h which we have, and we'll feed it the data, some more data, and it'll give us the labels or outputs. Okay, so this phase is called training, or maybe learning we can call it, and this thing is called as testing. Okay, or maybe we can call it evaluation. So this can be called as training or learning, and here we evaluate it because we test it. So I think this setup is clear. So the only point here is we want to find this h. So that is the whole job, and how to do that job, and we want to do that job by some algorithms. Is it clear?
Yes, sir.
Yes, sir.
Now we want to have some guiding principles. The whole point of finding how to find this h. Okay, the first thing is I will have this hypothesis class, and it will contain a lot of h. Let's suppose it will have h1, h2, a lot of functions, maybe infinite functions. So if you want to find this h, find a suitable h which does the good job of classification, which does the good job of the machine learning task that we have at hand. So one thing can be, you can choose anything at random. Let's suppose we choose anything, any h. Okay, so this is a terrible choice. So if you take any function at random and try to give it the data, it will spit out random output. That's not what we want. So that will be a terrible choice. The second choice, the first choice I'm saying is random. So if you take a function at random from the hypothesis class and you will try to give it the data and it will spit out some random output, this won't solve our problem. This is really terrible. The second thing is you can do brute force. You can take the first function and check for all the input and see how many labels it is, how is it classifying, and then take the second function and then see similarly how many, maybe let's suppose image, or how many data points it correctly classifies and things like that. It is too time taking. Do you agree on this point? If you have a hypothesis class, you have a set of hypotheses, you have a set of functions from that class, and you try each one of these, and you know that there are infinite number of these, so you will keep on doing this for lifetime. Okay, so random is not a choice. This is a terrible thing. And second thing is brute force. This is not a choice. Okay, so what can be the other choice then? Okay, so then we have to find some choice, and that there is a guiding principle. There is a guiding principle which I'll, maybe you will not find these terms somewhere, but it's okay. So what is a guiding principle? So guiding principles are the loss functions. Now my job is to find an edge so that I'll this edge behaves in a certain way so that I get my job done. Okay, I have a hypothesis, a lot of functions are there possible. So I'll not just choose randomly, I'll not do brute force, but I'll do something so that it gives me an appropriate edge. It gives me that function which I have to model, so that when I give it the query point, it gives me back the corresponding label, or what task I'm doing, it gives me correspondingly, it does my job basically. So the guiding principle I said is a loss function. So what is a loss function? So loss function is, it's a function again. Don't confuse by this. Hypothesis is also a function. We are trying to find that function. But here loss function is again a function. So now we have two functions at hand. Are you seeing the layers I'm building? So you should be clear with that, because when I was first time learning all these concepts, I was confused. What is this loss function? Okay, what is this hypothesis function? What are we finding? Okay, this loss function is a guiding principle. It will tell you, okay, if you chose this edge, so how good is it? So it basically this loss function says you how, like, it gives you a method to evaluate how good a hypothesis is, hypothesis function is. So now I'm choosing a loss function, let's suppose, and I want to evaluate how good is it, how good does it work. So for that I have a loss function. I have this loss function. I have to take a loss function, and then based on that I'll evaluate my function. So how I'll do that? For example, I'll call this loss function L. Okay, so I'll say, let's suppose I chose some h. So if I give it any point xi, okay, and this is, for example, this h, I give it some points from xi which belongs to data set. I can write it like this: h comma d. H means this is my loss function, and d means I test it on whole data set. So this is what I want to get minimized. So this should be minimized. I want my loss to be very less. And how to define loss? I'll tell you that. First, ingrain this in your head, that the point is we are trying to get this function. So we have a lot of data. We have this x1, x2, xn, and then we want to get the corresponding y1, y2 to yn. We want to get that. And I am in search of this function h. This I call as a function or hypothesis function. And then we have a hypothesis class. So whole class of functions in there. And from those functions, there is one best fit I can call, which gives the minimum loss. So by minimum loss, I mean that it performs better. Okay, so the guiding principle is I'll use loss function. So loss function of the hypothesis and this data set should be minimized. Let's talk about a bit about this. So there is one thing called as 0-1 loss. So 0-1 loss means, so if you take a data point xi, okay, and you give it a loss function, so if it is correct, so it will spit out some value. Let's suppose this will spit out some value. So let's suppose h of xi will spit out some value. So because we know correspondingly there will be a value here, it is a label, and it will have a label yi of its own. Okay, if it is not equal, so if the label was mispredicted, then we'll say loss is 1. Okay, if it is not mispredicted, if h of xi is equal to yi, that is the prediction made was right, then we'll say loss is 0. Is it clear? So this is a function. So let me call this function as delta. So delta, this is how delta is defined. So delta is defined that it's a function if h of xi is equal to yi. That means if this is the prediction, if prediction is equal to the label, then we say zero, there is no loss. That's why it's called binary loss or 0 1 loss. There is loss or there is no loss. Okay, let's suppose we have 10 data points. Okay, and for one of these we got let's suppose we got the right answer, then we'll say for other 9 it did not get the right answer. That's why we say sometimes this loss function, this binary loss divided by the total number of points gives us the accuracy. So how much accurate were we? So this is the prediction, this is the label. So if h of xi is not equal to yi, that means it's a misprediction. So we'll add 1, we'll say loss is 1, you lost something. That's why it's called loss function. So we're actually capturing the loss, how much loss you are in or how much gain you are in. So here it's called loss. So we want to get the loss as less as possible. Loss cannot be negative. Negative loss makes no sense in this realm. So here, if the prediction is not equal to the label, then we say you have a loss because you mispredicted the things. But if the prediction is equal to the label, then we say that you have no loss. You actually classified it. So this we call as misclassification. You'll hear frequently these terms. Maybe when you read papers or you read some books, there you'll find these terms. So then you this is correctly classified or correct classification. So where the prediction is equal to the label. So this is what is called as binary loss. Now I need to make this binary. I need to write it as a function. So I'll say this binary loss is let's suppose loss of hd. This is the loss. How will I write it? I'll say summation over all the points that are in data set. A summation over all the points. Let's suppose I'll write whole data set d. So what I'll do is I'll apply this delta function onto this xi, comma, then I'll write yi. So this xi here, xi belongs to data set. And I'll average it out. Total number of points. Okay. So do you see this? So this will give me sort of accuracy if you know. Oh. So how many of you understood this? Have you understood this? Riyan, Amir, Salim, Zubair?
Sir, if you repeat a bit.
Yes. So again, that's the reason I am trying to build layers of things. Whenever you don't understand, please tell me. This is the bare bone basics because now you have been through a mathematical training. That's why I want you to know all of this stuff. This is not that hard. I'll go again from here. So till this point, you understood everything. Is that assumption right? You know what is
Yes,
classification,
sir, yes,
what is
sir.
regression, and stuff like that. Now, the whole point of machine learning is to find a model, to find something. Let's suppose black box, to find a machine for which I'll give some input and it will give me the corresponding label. Let's suppose we'll take the running example of spam, no spam. So I'll give an email, and for the email, the output should be either spam or no spam. That's my job. The whole machine learning is based on that. So here, what I'm saying is that we need basically we need a function here. Okay, this h is a function. When I give the function an input, it will give some output, and this I need to find. This h I need to find basically. So I am telling there are a lot of h. So there is a whole class of h. There can be infinite number of possible h's. So all these h's I call hypothesis class. Okay, so there will be a huge number of hypothesis classes. So there can be infinite number of functions to which I give some values and they'll output something. Okay, so I'm saying I need to pick up the best edge among those hypothesis classes, and that is the job of my algorithm. My algorithm should choose the best edge. It should choose the best edge so that when I give it the input, it should give the correct label. In our example of spam and no spam, if I give it an email, so it should spit out spam if it is spam. Otherwise, it should spit out no spam if it is not spam. Then I said there is this training process. So this training process is when you find this edge in the algorithm, and then testing process is when you test this edge, evaluate this edge. So whole point is finding this edge. So how to find this edge now? I said out of these many hypotheses, out of this hypothesis, there are different hypothesis functions in this hypothesis class. So if I choose the things at random, there will be random answers then. So for example, if I don't train the model, I'll say give me an email. So with my eyes closed, I'll say spam, not spam, spam, not spam. This will be total random. It also is a classifier, but it's a random classifier. So it classifies things. So if you give me an email, I don't look at it. I say it's random. It's spam. You give me another email, I say no spam, spam, no spam, something like that. Because I don't look at the email. That is a classifier though, but it's a random classifier. Okay. So that is not a good choice, because you know that it will perform at random. You don't know how it will perform. Then the second choice is that if you want to find a function, so what I do is I'll brute force. I'll find all the functions that are there in the world, and I'll give them the input, and I'll get the corresponding output. Okay, so I'll test each of these functions. I'll take h1, I'll take h2, I'll test it on, I'll see which is the best, so where the misclassification is very less. So what will happen, it will take too long time. It will maybe take the life of universe, because there is infinite number of possible functions which I can use, which I can test. So then I said, okay, there should be some guiding principle, there should be some mentor, something to me who will guide me. Okay, if you want to find a function, like, take this, take my hand, probably, like, take my hand, I'll take you there. So then that guiding principle is loss function. So loss function is not the function that we want to find. The loss function guides us to the actual function that we want to find. Is this statement clear? Please listen to this statement again. Loss function is not the function we are interested in finding. Loss function is something we define. It guides us so that we hit the correct function, that is our function, which will be used as a model, and which will be used to will query, and then it will give some output to us. Is this much clear?
Yes, sir.
So what am I telling you after this is, so how to evaluate this loss now, like how to basically model it. So I'm saying the first function, type of loss function, is 0 1 loss, okay, or binary loss function. So in that, the loss means if you do misclassification, you will be in loss. The literal meaning of loss is that. So that if I give you something and you said wrong, so I'll give you some, maybe a slap or something like that, you are in loss that time. So that's what I'm saying. I'm saying, let's suppose I have this function h x of I. So if it makes a misprediction or misclassification, so if h of xi is not equal to yi, so then mean you have a loss. So you will give it a value 1. Okay, otherwise you'll get a value 0. That's why it's called a binary loss function. Okay, so this is the function which will, on misprediction, penalize you with 1, and when you are correct, it will give 0, that you are not in loss. And you will add all these losses. You will add all these losses, and then average it over. This is basically like accuracy. Okay, let me put in this in perspective. So let's suppose you have 10 emails now. I will call them email 1, email 2, till email 10. Okay, let me write it: e3, e4, e5, e6, e7, 8, 9, and e10. These are my emails. So there is some text written. This is the label corresponding. So this is spam, this is spam, this is not spam, spam, not spam, spam, not spam. Okay, let's suppose this is the actual labels these are, and these are my emails, the data points. So what am I trying to do is I am trying to make a prediction. Okay, prediction is made by using let's suppose I found some h, and I want to see how good is it. Let's suppose h is the function which I found, and I'm saying h of e1. So h of e1, let's suppose it predicted 1. Here it predicted 0. Here it predicted 0 1 0 1 1 0 1 0. Okay, this is what my h predicted. Now I want to evaluate how good is this h. So I'm saying I need to see binary loss function. So what I'll do is, because here you see this is exact, this is not a misprediction, so loss will be 0. So here loss will be 1, because there's a misprediction. There is no misprediction. There is no misprediction. No misprediction. No misprediction. Do you see it? So I think here is a misprediction.
Yes, sir. Yes.
Yes, here it is. So if you see the misprediction total, so I'll add these 3. The total is 3, but total number of points is 10. So I have the loss of 0.3. Usually I call it accuracy. I have the accuracy of 90% and miss accuracy of this. So I have loss function is this. So if I need to accuracy is 1 minus 0.3. That is 70% times it's accurate. Okay, so accuracy basically is the 1 minus loss function. Whatever loss, binary loss that it gives you, 1 minus loss is the accuracy, if you see it. So how many times was accurate? It was accurate 7 times. How many times what is wrong? It was wrong 3
Three
times. So
times.
I'll say 3 by 10. So this is here is my binary loss. So that's what I wrote mathematically. Summation of delta. Delta means it's a function itself. It's a loss function. This is a binary loss function. So binary loss function is defined over here. So this delta is defined over here. That's how I defined it. So if it is making a misclassification, I'll write number 1. If it is making a correct classification, I'll add number 0. So and then I'll average it over. That's what I said. Mathematics basically is a language, and you should know how to read this language. If you have to read this equation now, so you'll say loss of this hypothesis H on data set D is equal to the average of this is average, because the summation plus 1 by n is average of this binary loss. What is binary? If there is a misprediction, the value will be 1, and if there is not a misprediction, the value will be 0. So adding all of these together and dividing by, and basically taking the average of the losses, okay, that is defined as loss of this h over the data set D. Is it clear?
Yes, sir.
How many of you have understood this loss function? So what is a loss function then? It's just a guiding principle. Okay. We read about this first loss function. That's the binary loss, and it is 1 minus of binary loss is accuracy if you see it in that realm. So now we have something called as squared loss. Again, reiterating, loss functions are the guiding principles which help us evaluating a function, a hypothesis function. So if you have a function, you want to see how better it is, so you will use these loss functions. What is squared loss function? So what you will do is you will take h of xi. That is the prediction. You will make prediction based on this h, because you will give input to the h xi, and let's suppose you will get some y cap, y hat. It's called as prediction. Okay, and then it will be subtracted by the actual label, whatever actual label or actual the value corresponding value was, and then we'll square it and sum it over all the data points. So howsoever we have 1 to n, and then we'll take the average of this. So this is the squared loss. So what square loss is, if you remember this, we have done this as linear regression. If you remember the concepts in linear algebra and other things
Like
accompanying that,
standard deviation.
you can, standard deviation is something else. There we take variance and things like that in account. So here you will see we have this function which is a prediction minus the actual label. So this is prediction minus the actual label. Okay, then you square it up. Okay, then you sum all these predictions, whatever predictions you make. Again, in this, if I have to see take this in this context, so here if I have some emails, and let's suppose these are y hat is the predictions and y is the actual thing. Let's suppose actual where we have 10 values, 1.0, 1.5, 1.3, 1.6. Let's suppose we'll take 5 values only, 2.8. So let's suppose this was the prediction. Let's see actual. Let's suppose actual was 1.1, 1.8, 1.6, 1.5, 2.8. Let's say these are the actual things. And if I now want to see the squared loss, what I'll do is I'll subtract this and square these things. So this will be 0.1 square plus 0.3 square plus 0.3 square plus 0.1 square plus 0 square. After summing up all of these, then I'll divide it by 5. So this over here will be my squared loss. Okay? Is the squared loss clear? So again, reading it in English, it means take a prediction, subtract it with the original value, the actual value, and then square the things up, and then take the summation and divide by the total number, and basically take the average of these things. Take all the data points and take average of this. So this is the squared loss. Then we have one more type of loss which we call as absolute loss. Let's call it. Okay, so we'll call it absolute loss. Again, telling you the same thing. These loss functions are the guiding principles by which you evaluate the hypothesis function. You have a function and you want to see how good is this function. That's the job of this. Because sometimes people get confused by this loss function and the actual function that we want to find. Loss function is a principle, is a guiding principle by the help of which we try to evaluate the function, actual function that we want to find. So in the absolute, what we do is you again have a prediction. Okay, you subtract it by actual value, and then you take the absolute value of that, and then you sum it over all the data points. Let's suppose 1 to n, and then you average it out and you divide by the number of data points n. You see, like there is a difference between this squared loss. It has its own, like if you know differentials, I can tell you this is a really good, like squared loss is really good. Why? It's differential, it's differentiable and continuous, because we need differentiation in finding gradients and stuff if you have watched the previous lecture, but I won't go into that detail. But here, if you see absolute loss, what it does, so it will not square the things up. So it will just make the things positive. If it's a negative thing, then it will make the thing positive. So why to use this and why to use this? So where will this basically fail? If there is an outlier, let's suppose I am predicting the house prices. So I want to predict the house prices. Okay. So if there is a misprediction by the classifier, let's suppose Bill Gates' house was mispredicted by a lot. So let's suppose Bill Gates' house was costing $1 billion, and we predicted it to be 100k dollars. So there is a huge misprediction. So if you square it up now, the misprediction will become way more. So this actually is penalizing it more, because it's squaring it. So it will penalize and you know that by outliers, this is disturbed. The mean is disturbed. It is taking the mean of the misclassification. So if you see that, so by taking the mean, and it will square it up and it will make the error bigger. So that problem won't be here. So if you have an outlier, maybe we can manage because it is not squaring it up. Okay. So if you see something that it has a lot of outliers and things like that, maybe you don't want to go with this function, because the problem here is it will penalize a wrong thing very high. So if you have, let's suppose, a penalty of only 10, it will remain 10 here only in the absolute loss. But if you see, it will make it 100. It will square it. Okay, but this is its own pros also. So as I said, this is a really good function. It's differentiable. So if you want to compute mathematically some things, look, because you will heavily use a differentiation tools and things like that, and this function is differentiable. But sometimes you will have to look at the data. So if you see there are a lot of outliers, or maybe there is something, let's suppose, that's called anomaly. Anomaly is if somebody has sold a house for $1, and they, like, people usually use it to save taxes. So I'll sell my house to my brother. I'll just I'll just take $1 for him. So when the data will go to the government, they'll see this house was sold in $1 only. So why? Because he has just transferred it to somebody else, and when it will be in the data. So for on that time there will be a huge penalty, because obviously, seeing the house, our algorithm will predict a lot higher price, but the actual price that was sold for was only $1. So then you will see that this algorithm will penalize it a lot. Okay, and this algorithm will be sort of a bit soft. So these things have their own implications. And now you saw where can we use a square loss, where you have, like, if you have a classification problem, either maybe a multi-class classification or binary class classification, then you can use the binary loss. You can use the metric accuracy 1 minus binary loss. And where to use the square loss? Square loss can be used in the regression problems, because this will be a continuous value. So there you will have to see. Okay, then we also see something called as mean square error. So you can also call it as mean square error, this thing, MSE. Okay, this is also called as MSE, because you are taking mean and then you are squaring it, and then you are taking the average. That this is average, mean, squaring. This is error. This is called mean square. Then there is something called as root mean square error. If you apply root onto this, okay, then this is called as root mean square, RMSE. So all of these basically are loss functions. I just wrote them as functions, and sometimes you will, if you read a book, there you will see them written as metrics, and we'll again go through all of these metrics that time, and we'll see what's the meaning of RMSC, MSC. As you saw it there, you will just make a list of these things. Then we have something called as F1 score, precision, recall, area under curve. There are a lot of other metrics as well, but I just wanted you to introduce to these loss functions, because sometimes you'll see a book where there is written that we have a loss function, its value is this. So is the loss function clear?
Yes, sir.
Okay. Now what we want to do is we want to find this loss function. Okay, we want to, like, use this loss function to find the actual function. The loss function is there. We'll define loss function and we'll find the actual function. So loss should be minimized. So the question here is, my loss should be minimized. This is my target. Whatever loss function I use, I want its minimum value. Okay, so L of loss function of hypothesis on the data set should be very less. So this is my point. This is the thing that I want to do. So how can I do the classifier? So what I can do is, let's choose a classifier again. First, I chose a random classifier that gave random input. I tried brute force. That was again a terrible situation because it will take infinite time. So what if I do this? What if I make a classifier which I'll give it it'll basically memorize the whole data set. It'll basically memorize the data set. So I'll make h of xi is equal to yi. So this is for all xi belongs to data set. And for other thing, I'll give, let's suppose, w1 as answer. So let's suppose this is my classifier. So what am I saying is, I'm saying I'll make purposefully a hypothesis like that. Whenever you give xi data point from the data set, so it'll give y, it'll give its corresponding label. So this is basically memorization. It is memorizing the data set. So whenever you are giving the point which is in the data set, it is giving the output label. So, but whenever you are giving some other point, it will basically spit out anything. Okay. So what do you think its accuracy will be? Is it a good idea to have a classifier like this? What do you feel? First, tell me, have you understood this classifier? What is it doing?
Yes, sir.
So what is this classifier doing?
सर it's doing दस मतलब कि क्लास में है कि नहीं?
So it is basically, no, it's not doing that. What is it doing? It, if it is in the data set, so if you give the point among the data set, okay, it will spit out the label because it has memorized all the data set. For the other points, it doesn't know. Let's suppose I have images. So there are cats and dogs images of billions of dogs and cats. So let's suppose now I have a data set which only has, let's suppose, 10,000 points in that. So what this classifier does, it memorizes everything. It memorizes each and every dog from this and each and every cat from this. So if you give a data point from here, from the data set, it will correctly classify it. But in the other way, for example, now you captured a picture of dog that was not in the data set. So if you give it this picture because it was not in the data set, it will spit out anything. Okay, it will be basically random, some random thing. So do you think this classifier is good?
No, sir.
What do you say, Rihan? Is this classifier good?
No, sir, because of the random result.
Because it only performs good on data set that we have. That is what it was trained on. So this is called as memorization. So what it does basically is, it is like that guy, whatever he's being taught in class, he knows that. But if you ask him extra questions out of the class, he doesn't know that. Okay. So whatever he's being taught, for example, let's suppose math teacher solved 10 problems, he knows how to solve them. But the problems which were left for the homework, he did not do that. And when he went for the test, and then he saw that, oh, I haven't practiced this problem as well. Okay, I don't know how to solve this. That's what is called as generalization. So generalization, this is the concept. So we don't want to see a classifier on which the on the training data set it will perform really good, but when it is actually tested, it performs terribly. Okay, that is the generalization function. So what I want to do is, so my generalization says that you should find a loss function. Okay, basically it should give me the minimum value from that function. We'll write the argmin. Okay, h should be equal to argmin of, argmin basically means find me this h which has the minimum loss. So this is what is the definition of that loss function, what I want my loss function to do. So big part is that now I want the generalization. So generalization means, on the, there is this data is actually, if I speak about probability, this data x I comma y I, it is drawn from some distribution. It has some distribution, and now distribution has, let's suppose, a huge number of points. So we cannot collect all the data points, and there is no point of doing machine learning. Machine learning is based on the assumption that we'll train on maybe a subset, maybe what's called a sample. We'll train on a sample, then we may test it anywhere. Okay, it is drawn from some distribution, God knows, because we don't know this distribution. Nobody knows this distribution. If somebody knows this distribution, then problem solved, machine learning gone. Then we don't have to know machine learning. So these samples are drawn from some distribution, and then a set of sample which we call as d-train. We'll take this d-train, and then we'll have a set of samples which we call a d-test. So here we'll train the model on this, we'll evaluate the model on this. If it gives good accuracy, then we'll deploy it in the real world. Then the samples will come which the machine learning model has not neither seen in training, neither seen in testing, and we see how good it generalizes. So generalization means how better is it performing on the unknown data set, on the unseen data. Okay, so generalization basically means how better is it performing on unseen data. So on the seen data, on the if it is performing 100% and it is terrible performing unseen, that's called overfitting. So we'll read about these concepts in detail, what overfitting means mathematically, but just at this point understand that if there is a classifier which really fits to the data, so to the training data, and you gave it some training data, it really performs well on that. But when you test it, it performs terribly. Then you say it's overfitted because it has probably memorized everything. Okay, so in order to mitigate that, we'll just have detrain and we'll have detest. We'll split the data and we'll train it on some data and we'll test it on some data, and that will have something called as validation also. So you will also split this detrain into two. So you'll say detrain and devalidation, and then you will have this detest. We'll read about something called as k cross fold validation. We'll read about all of these things, how to split data and how to train this data and things like that. And even this is a huge problem, like how to split the data. There are duplicates sometimes. So let's suppose, I think I have heard this story from somewhere. They were making a spam classifier. So every email in dtrain was also in dtest. So when the model was trained on this dtrain, it was giving 100% accuracy. They were saying that spam problem is solved. But the problem was whatever email was in the dtrain, it was also in the dtest. That's why you have to check for duplicates. So these points should not be similar. Dtrain and dtest points should be totally dissimilar. That's why in the ED assignment you have removed duplicates. How many of you have done that ED assignment in which you remove duplicates?
Yes, sir.
And you also remove those null values, that not
Yes,
the
sir.
number values. You also might have done that. That is you have, because that's the pre-processing here. Otherwise, if you have that, it'll perform terribly. And like recent, I'll pause here recording for a second because I'll have to give my report. So that's why you should be really careful. So among the 100, you had only 41 of class 1 and 959 samples of class 0. So when you will do, even if you have a random classifier, so random classifier will be 95% times accurate. If you just say everything belongs to class 0, everything belongs to class 0. So this is imbalanced data set. That's why you have to learn how to deal with imbalance. So there are techniques, something called as oversampling, undersampling, and things that we'll learn. I just want you to tell you that this detrain and detest is a really tricky part. You'll have to really spend some time over there and to check the data if there are overlaps, if there is not a numbers. So you'll have to deal with those things. So the whole of the discussion, it started from this generalization. So what we want to do is, generalization basically means whatever the hypothesis function we chose from the hypothesis class, which we think is good. So it should perform better on the data which is unseen, on which it was not trained. Okay, is that clear?
Yes, sir.
Okay, if that is clear, then what now we need to find this h. Okay, for this h we have algorithms. So in order to find this h, we have algorithms, and in order to evaluate, we have loss functions. Is everything like? Are you imagining the thing? So we had a problem. Let's suppose classification problem. So we have been given some data points. So we split the data. So we said this is our training set. This is our testing set. We have some training and some testing. On training, let's suppose pick up a function h. Pick up some function. So we'll find that function by the algorithm. Okay. This algorithm will help us to find h. In order to evaluate h, we have come up with loss functions. So we had squared loss, we had the 0 1 loss or binary loss, and then we had this what we call as absolute loss, and we'll use these functions to see, to evaluate how better this function is. Okay, now we'll delve into these algorithms. Now we need to find the algorithms by the help of which we can find this h. Is it clear why do we need algorithms?
Yes, sir.
So even why can't there be only one algorithm? That's a question. Let's suppose we have only one algorithm that is able to find this h really good. So for that, the assumption is that different data has different assumptions. Different data is different. Okay. So we have different data. So for that purposes, we cannot use. We have different data and we assume different things about the data. Okay, for that purpose, we have different algorithms, and different algorithms perform really way different on different data sets. So you'll have to look at your data set and you'll have to see what I assume about my data set. These are the assumptions. Okay, then maybe I'll use a certain algorithm. Is it clear?
Yes, sir.
Nice.
Yes, sir.
So now the first algorithm that I'll teach you guys is called as KNN.